2061 Odyssey 3 Space Odyssey Series. Chapter 8 Starfleet. Sir Lawrence Song was not a sentimental man and was far too cosmopolitan to take patriotism seriously, though as an undergraduate he had briefly sported one of the artificial pigtails worn during the Third Cultural Revolution. Yet, the planetarium reenactment of the Shin disaster moved him deeply and caused him to focus much of his enormous influence and energy upon space. Before long, he was taking weekend trips to the moon, and he had appointed his second youngest son, Charles, the 32 million Sol one, as vice president of Song Astrofreight. The new corporation had only two catapult-launched, hydrogen-fueled ram rockets of less than 1,000 tons empty mass. They would soon be obsolete, but they could provide Charles with the experience that Sir Lawrence was quite certain would be needed in the decades ahead. For at long last, the space age was truly about to begin. Little more than half a century had separated the Wright brothers and the coming of cheap mass air transportation. It had taken twice as long to meet the far greater challenge of the solar system. Yet, when Luis Alvarez and his team had discovered muon catalyzed fusion back in the 1950s, it had seemed more than a tantalizing of only theoretical interest. Just as the great Lord Rutherford had pooh-poohed the prospects of atomic power, so Alvarez himself doubted that cold nuclear fusion would ever be a practical importance, or would ever be of practical importance. Indeed, it was not until 2040 that the unexpected and accidental manufacture of stable muonium hydrogen compounds had opened up a new chapter of human history, exactly as the discovery of the neutron had initiated the atomic age. Now, small, portable nuclear power plants could be built with a minimum of shielding. Such enormous investments had already been made in conventional fusion that the world's electrical utilities were not, at first, affected, but the impact on space travel was immediate. It could be paralleled only by the jet revolution and air transport of 100 years earlier. No longer energy limited, spacecraft could achieve far greater speeds. Flight times in the solar system could now be measured in weeks rather than months, or even years. But the muon drive was still a reaction device, a sophisticated rocket no different in principle from its chemically fueled ancestors. It needed a working fluid to give it thrust. And the cheapest, cleanest, and most convenient of all working fluids was plain water. The Pacific spaceport was not likely to run short of this useful substance. Matters were different at the next port of call, the moon. Not a trace of water had been discovered by the Surveyor, Apollo, and Luna missions. If the moon had ever possessed any native water, eons of meteoric bombardment had boiled and blasted it into space. Or so the selenologists believed. Yet, Clues to the contrary had been visible ever since Galileo had turned his first telescope upon the moon. Some lunar mountains, for a few hours after dawn, glittered as brilliantly as if they are capped with snow. The most famous case is the rim of the magnificent crater Aristarchus, which William Herschel, the father of modern astronomy, once observed shining so brightly in the lunar light in the lunar night. Once observed shining so brightly in the lunar night that he decided it must be an active volcano. What he saw was the Earth light reflected from a thin and transient layer of frost, condensed during the 300 hours of freezing darkness. The discovery of the great ice deposits beneath Schrader's Valley, the sinuous canyon winding away from Aristarchus, was the last factor in the equation that would transform the economics of spaceflight. The moon could provide a fueling station just where it was needed. High up on the outermost slopes of the Earth's gravitational field, at the beginning of the long haul to the planets. Cosmos, first of the Song fleet, had been designed to carry freight and passengers on the Earth, Moon, Mars run, and as a test vehicle, through complex deals with a dozen organizations and governments. Of the still experimental Muon drive, but at the Embrium shipyards, she had just sufficient thrust to lift off the moon, from the moon, with zero payload. Operating from orbit to orbit, she would never again touch the surface of any world. With his usual flair for publicity, Sir Lawrence arranged for her maiden flight to commence on the 100th anniversary of Sputnik Day, for October 2057. 2 years later, Cosmos was joined by a sister ship, Galaxy, was designed for the Earth-Jupiter run, and had enough thrust to operate directly to any of the Jovian moons, though at considerable sacrifice of payload. If necessary, she could even return to her lunar berth for refitting. She was by far the swiftest vehicle ever built by man. If she burned up her entire propellant mass in one orgasm of acceleration, she would attain a speed of 1,000 kilometers a second, which would take her from Earth to Jupiter in a week, and to the nearest star in not much more than 10,000 years. The third ship of the fleet, in Sir Lawrence's pride and joy, embodied all that had been learned in the building of her two sisters. But Universe was not intended primarily for freight. She was designed, from the beginning, as the first passenger liner to cruise the space lanes right out to Saturn, the jewel of the solar system. Sir Lawrence had planned something even more spectacular for her maiden voyage, but construction delays caused by a dispute with the lunar chapter of the Reformed Teamsters Union had upset his schedule. There would just be time for the initial flight tests and Lloyd certification in the closing months of 2060 before Universe left Earth orbit for her rendezvous. It would be a very close thing. Halley's Comet would not wait, even for Sir Lawrence Song.